Okay, so if we draw our little line segment again with length 1, we go over 0.53 and we get a square whose area matches a circle whose circumference comes from this bit. And that isn't all that surprising that we had to go a little bit more than halfway. Here the area is x squared over 16. Here the area is something squared over about 12, right? A little bit more than 12. So this side should be a little bit shorter. This side, sorry, here should be a little bit shorter. But again, we got the second solution. And what does that tell us? What does that mean? Well, it says if we take a square whose side goes all the way out to here, and a circle whose circumference is given by that, that also works. So that's interesting. The quadratic formula, which produced two solutions, actually gives us two solutions in the picture as well. It's just this point isn't on that line segment. And that causes you to ask the question, or at least I think you should suggest the question, what about other solutions? Well, so what can we say? Well, the point has to be farther away from A than it is to B. So if we divide the line segment in half here, we know there won't be any solutions in the plane that are over here, but there are going to be some over here. And now you can just write down an equation for any point xy over here, calculate the distance from the origin, calculate the distance from this point, which will be 1, 0, and find all the solutions. And you get a nice little equation, and it turns out pretty miraculously, I think to a lot of students, the equations say it right away, you get a circle. You get a circle in the plane. And, going through this Tuesday morning with my son, this was amazing. I thought this was really interesting to see that this second solution gave you a clue that there were way more solutions, not just this one that was on the line segment. So that was a lot of fun. And of course, there's some fun stories in the history of math and science about solutions to equations producing real results in the physical world. I think the most famous that you could draw the analogy with here is the solution that Dirac found to the electron equation, where there was a second solution, and he proposed that second solution must represent something physical. And later, people went on and found positrons. So, I don't know. I thought this, look, I'm not saying this is the same as that, but I thought this was interesting. And I thought that this second solution leading to this finding the circle in the plane to produce all these solutions, I thought it was pretty interesting. I thought kids would really enjoy seeing that and working through that and seeing this physical connection between the second solution that comes up when you solve for this and where that led. So to me that was interesting, and to me that was a lot of fun going through this with my son Tuesday morning when I first saw the problem. All right, thanks for watching.